Yes, sir.
Okay. Where we have started the journey, if you can recall the course outline or course, what we have started, or from where we have started the journey, we have set 5 different course objectives to address this course. There was course objective 1 was formulate one line diagram regarding impedance diagram or the for the given power system, right? You have to respond whether we can satisfy that, or if you have been given some online diagram or impedance diagram for the power system, you can generate, right? Have we completed that course objective 1? Let me get some feedback from your side, whether you can formulate the one line diagram for the given power system. Okay, have you all of us joined?
Assalamu alaikum, sir.
Walaikum salam. Okay, Tasin naki?
জি স্যার, এই যে একটু আজকে ঘুম থেকে উঠতে একটু লেট হয়ে গেছে।
How was your experience regarding the program?
স্যার, the park was it was really nice, sir.
Have you attended all the sessions?
স্যার, লাস্ট ডেতে স্যার আমার হচ্ছে আপনার লাস্টের দিকে একটা সেশন মিস গেছে। তো ক্লাস ছিল বলে স্যার আড়াইটারটা, আর তার আগের দিনে হচ্ছে স্যার লাঞ্চ করার জন্য একটা সেশন মিস গিয়েছিল। তা না হলে সবগুলোই করেছিলাম স্যার মোটামুটি।
How was your feedback? What was you have achieved, or what is there any direction or anything you want to mention that it was helpful regarding that perspective?
So especially the power sector, yes sir, especially that in the power sector we had no idea, sir, what were the things or topics that were mainly currently the hot topic or the thing that are being worked.
So there was some microgrid aspect for first session, right? Microgrid aspect.
Yes,
and
sir.
There you have some discussion. Actually, one resource person was telling, meaning that you have to apply those load flow study. If you can recall the Gauss-Seidel and Newton reaction in terms of advanced level, you have to have the base so that you can extend that idea for the upcoming area or upcoming research or upcoming ideology.
Yes, sir. Yes, sir.
So
he made his own algorithm, sir. Yes, sir.
Yes, he made his own algorithm, but based on that basic algorithm or basic idea, you have to first have that. Otherwise, if you don't know the basic philosophy, in that case, it will be difficult, or it will not be possible for you to manage that issue. That's the motivation regarding that. And beside that, there was other session regarding different aspect for that. Actually, the main idea was to give a link between this course or this system, power system or anything, so that you can extend those idea future. As well as you may have another course which will be on probably next year or the next to next year, the last power system third course. Okay, in that course you may get also other additional feature as well. Okay, beside that, this is the second course, and you will have another third course in the third or fourth year. Okay, I may not get that exact semester. You may get the extended version. So the remaining discussion of those power system will be covered on that course also. So for the time being, what we have shared in the very beginning of this course, let me point out those issues. We have mentioned we have to cover those 5 different aspects of this course. So let me get your feedback regarding those aspects. Course objective 1, whether we can satisfy that or not, based on your practical or based on your achievement from this course, whether you can satisfy that or not. Course objective 1, formulate one-line diagram. I think you can generate one-line diagram of the given power system. You can also generate impedance diagram. Can you do that?
Yes, sir.
Yes, sir. Yes, sir.
Okay, you can do that, right? So we can satisfy course objective 1. Second objective was interpret Y bus and Z bus. This was the second objective, matrix for power system. Actually, what was the idea for Y bus and Z bus? Or you can generate that also from the impedance diagram, right?
Yes,
or
sir.
interpret different aspect of those Y bus as well as Z bus. So second objective also we have satisfied, right?
Yes, sir.
So if you have been
Yes, sir.
given any system, yes, any
No, sir. It's fine,
addition
sir. No,
for
sir.
your, okay, fine.
We got.
You can also do that. Second objective is also satisfied. Third one was evaluate power flow problem, that is the load flow study, using different numerical methods like Gauss-Seidel method as well as Newton-Raphson method, right? So
Yes,
you
sir.
can evaluate those power flow problem using different method. Third course objective also was satisfied from your perspective, right? So we
Yes, sir.
can do that if it is given. Fourth objective was recognize the role of analysis tool of operation of power system. Actually, this part is covered in terms of more in the lab part, like MATLAB, PowerWorld software. Those analytics tool was used to address those issues, or you can identify the different aspect of those tools, right? Different tools was there to address those issues regarding the operation of power system. Power
Yes,
World was delivered by myself in the lab 3. So that tool is helpful to address those issues. Besides that, you can also identify the MATLAB usefulness regarding those issues. I think second lab was done based on that, right? Simulating MATLAB, those things.
Yes, sir.
So last objective was consider symmetrical component techniques for unsymmetrical fault analysis. That was the last topic we want to cover. Actually, in last quiz, you had that issue, whether we can solve the problem and we can generate the symmetrical component for unsymmetrical or symmetrical fault scenario. So all the course objective, we have set 5 objectives regarding this course, and I think I have managed to cover all those topics. Do you agree that?
yes, yes, sir. Yes, sir.
Yes, sir.
If you, yes, that's the satisfaction of this course, and additional topics regarding that. Probably this will be your last week regarding this course, and we have achieved these 5 objectives from this course. Okay, so this was the COPO mapping for that, and in terms of Bloom's taxonomy. I want to share another thing. We have already done that symmetrical fault analysis or unsymmetrical fault scenario. Today we will try to recap those issues in terms of balanced fault. Actually, we have done the unbalanced fault, and in that case, some part of the balanced fault was also discussed. Okay. So balanced fault was mentioned, which was the 3-phase fault. And 3-phase fault can be addressed by 2 different methodology that will be shared today. And after this class, I think we can mention the finishing line, that what will be the semester final objective, or what will be there, or that thing. Okay. So be careful regarding the attention of this course, this class. Okay. So if it is there, so balanced 3-phase fault, we know already the balanced 3-phase fault issue, right? from the last class lecture or last class discussion or last topics, we have addressed that balanced three-phase fault. What does it mean by balanced three-phase fault?
So all the three phases are short circuited.
So
Right.
fault.
Three-phase has the fault, right? So
Yes,
when
sir.
we consider that balanced three-phase fault, there might be fault impedance, there might be another condition like bolted fault scenario. Okay. So have I mentioned that bolted fault case scenario earlier? If it is mentioned in the problem that bolted fault scenario, can you address that issue? What does it mean by bolted fault scenario?
So I forgot, sir. বলেছিলেন, sir. You told us this. I forgot.
বলছিলাম, আচ্ছা, it will be there in some problem. It might be there. Actually, bolted fault scenario is that case if you have fault impedance as 0. You can see here,
Oh, yes,
fault
ZF has
impedance is
ZF.
0 is considered or referred as bolted fault or solid fault. Okay.
Yes, sir.
So you may have bolted fault, you may have fault impedance given. If fault impedance is 0, in that case, that will be bolted fault. So we want to address one to have that balanced three-phase fault scenario. For that case, 100 MVA base is used, and information here you can see ZF has the impedance of 0.16 per unit, right? So is it bolted fault case or not?
So not bolted fault case.
Not bolted fault, right? If it is bolted fault, it will be 0. So it has already the value. So you have to use that value for the problem. Now, if it is balanced three-phase fault and that scenario is addressed by what is mentioned here, it is the three-phase system. The diagram is already more common or familiar to you, right? This diagram is mentioned in the problem of 10.5 as well, if you can recall, right? Can you recall that diagram orientation?
Yes,
Probably
sir.
value may not be same, but the diagram orientation is same. So you have YY configuration there and del Y configuration in right side. So in this case, it is mentioned that bus 3, bus 2 and bus 1, 3 different scenario is there, and you may have the fault case like bus 3. If it is three-phase fault at bus 3, what will be the line impedance or line current? In that case, you have to find fault bus voltage. So to address those issues, what you have to do, you may solve that by Thevenin equivalent, right? First of all, you have to address that in Thevenin equivalent. So when you want to address that, if you have fault bus 3, the bus impedance can be represented like this, right? The fault bus will have the impedance which is given already in terms of fault path, right? So if you have fault, what will happen? It will generate a short path between that bus and ground in terms of that fault impedance. Is it okay?
Yes, sir.
Okay, if it is okay, we can replace that drawing with the Thevenin circuit, Thevenin voltage, and the impedance is there to address that fault current through this path in terms of bus 3 fault. So as we know that bus fault can be managed by the impedance for that particular node and the fault impedance together. Is it okay? This part for three-phase fault, this I3F will be nothing but, from this figure you can see I3F will be this from this terminal through that actually up to this third bus you have equivalent, which is the Thevenin equivalent, and ZF you will be there and you will have the voltage source in terms of third bus at initial value or pre-fault voltage is V30 means initial value of the third bus voltage, which is assigned as 1. For Thevenin equivalent voltage, you will have that issue. So we can generate, this one is mentioned here also. V30 is 1. Also the V10 and V20 is 1. Okay. You have to
is it given,
consider that it will be for pre-fault scenario. Okay, for pre-fault scenario, initially all the bus voltage will be 1. That's the standard assumption.
Okay.
Standard assumption for pre-fault bus voltage. This is the pre-fault bus voltage. Okay. Before fault occurs, pre-fault bus voltage will be equal to 1 per unit. If there is any fault, in that case, the voltage value will be deviated from its original value or pre-fault value, initial value from 1 to another value. Okay. So this is the equivalent Y of that delta, inner delta. And you know already how to address that equivalent circuit in terms of this part. That means from upper ground to node 3, this is Z. Is it clear, this diagram, this part?
Yes, sir.
If it is okay, we may proceed further Z33, and this will give you the idea of fault current in terms of this bus 3 during fault F. So we can find the I3 current. When we have I3 current, as we have actually two generator paths, generator 1 and generator 2. So we can get the two generator path current based on current divider rule. This is the total fault current, right? I3F. So if we just want to get the fault current in that generator path 1, we can find that as well. Can we do that?
Sir, can
Yes,
you
sir.
repeat the last thing you said?
If we have fault current I3F, the total fault current, can we get the fault current during that bus 3 fault for generator 1? This path is for generator 1. If we can check the diagram, this is the generator 1, right? This is generator 1, this side, and this is generator 2, another side. Right? So generator 1, what is the contribution of the generator 1 during fault? Generator 1 current. IG1.
Current divider rule.
Yes. We have to apply to get the component of this total fault current. Okay. That will be there in the next part, which is IG1 and IG2. The current contribution of those generator during fault, which is the partial or current of the total fault current, I3F. Okay. So here you can see the deviation response due to that fault current. This is the fault current or generator 1, and that is the impedance of that path. That will give you the drop, which will be deviated from the original position of 1. Okay. So that will give you the voltage, bus voltage of bus 1 during fault. Is it okay up to this point?
Yes, sir.
Okay. Tasin, is there any confusion up to this point?
No, sir. No, sir. It's all cool, sir.
So
আমার একটু স্যার নেট একটু সমস্যা হচ্ছে স্যার, আমি আসছি স্যার, আবার অফ বের হয়ে আবার ঢুকছি স্যার। Okay.
Okay. So when we have determined fault current as well as bus voltage during fault V1, V2, V3, so we can now determine the line current as well. Can we do that line current calculation based on that fault bus voltage?
Yes, sir.
So if we want to find I12 during F, that will be simply V1F minus V2F, which is 0.68 over the impedance of that branch Z12. And Z12, let's see what is the value of Z12 in that diagram. That was the Z12 information, right? 0.8 line impedance of Z12. So Z12 is the impedance value of the line between bus 1 and 2. Okay. So we can find the line.
So one small question.
Yes.
Sir, can you kindly explain the diagram how we got the voltage divider rule from there? Just like
current divider rule.
Yeah, sorry, current divider. Okay,
current divider.
Okay.
So actually, this was the diagram, right? This diagram is okay.
Yes.
Is this diagram okay? The fault current.
Yes, sir.
How
yes,
can
we do
find
parallel,
fault
then
current?
series, then this.
Yes, this will generate Z33, the resultant. Okay.
Yes, sir.
When you make that parallel and series, that resultant will give you the Z33.
Yes,
this
sir.
part. And this
Yes,
is
sir.
already given, ZF.
Yes, sir.
Okay.
Yes, sir.
So we can
sir,
find the
sir,
fault current.
এই Z33 টা তো স্যার আমরা Y বাস ম্যাট্রিক্স বা Z বাস ম্যাট্রিক্স থেকেও পেতাম স্যার যদি ম্যাট্রিক্সটা দেয়া থাকতো।
Yes, if it is given direct matrix, in that case you can just collect that information from that matrix. Okay. Otherwise you have to determine. If it is mentioned that you have to solve by Thevenin concept, you have to determine that Z33 by yourself because it is not given.
স্যার
But
ফলটা
if it is
যেহেতু স্যার
given, you can use that.
স্যার ফলটা যেহেতু স্যার বাস 3 তে এজন্য স্যার Z33 যদি বাস 2 তে হতো তাহলে Z22 হতো।
Right. If it is in that bus 2, in that case it should be Z22. You have got the point. এখন তাসিন তোমার যে কোশ্চেন ছিল fault current divider rule, right?
Yes.
This is the total current, fault current, right?
Yes, sir. Yes.
So if we just want to get that fault current component for that generator path and that generator path, you have two generator paths, right?
Yes, sir.
This is one generator path and this is another generator path. So if we just want to get the component of that total fault current I3 in terms of that path, can we find that? A current divider rule policy?
Yes, sir. Now we can. Yes, sir. Yes, sir.
0.6 over this total 0.6 plus 0.4.
Yes, sir.
This is mentioned here, right? IG1 is 0.6 over 0.6 plus 0.4. You have to consider reverse branch because it is current divider rule.
Yes, sir. Yes,
Okay,
sir.
so the component of the total current in terms of IG1 path.
বুঝতে পেরেছি স্যার। Yes,
Generator
sir.
1 path.
Yes, sir.
Okay, when you have generator 1 path, you can consider the voltage drop over that generator path considering the impedance attached to that path. Drop over that path will be this current and impedance of that path up to V1, which is
Yes, sir.
0.2. So we can find the drop over that path. And as we have considered V1F initially V10 as 1, which is the pre-fault or before fault voltage, standard voltage is 1, that is deviated by this drop 0.24, and it will give you the fault voltage, fault bus voltage. Yes.
So where are you getting
okay
that?
Now
That is zero when you get that delta V1 is equal to 0. Where is that zero coming from? 0 minus into bracket.
This one
From delta
this
V1.
one V1 0.
V1 0. That 0. Where is it coming from?
This
zero,
delta 0 V1.
Yeah, 0 0 minus that.
This one is.
Yeah. Those
Actually,
zeros.
you have to consider there. This is the delta V1 in terms of which domain, which direction. This is 0 in terms of
Generator 1.
Drop scenario, right?
Mm-hmm.
You have to consider the drop. What is the voltage there?
0.
0.
Yeah.
And you want to reach at 1. So you have to consider this one over the drop current, right? Over this path.
Yes, sir.
From there, you can get the drop for that V1. That means from 0 to V1 to reach there, what will be the deviation or difference for that delta V1?
0 minus that, yeah, that voltage group. Yeah, I've got
Yes,
it. I've got
that's
it. I've
the
got it.
drop.
Yeah,
Drop
got
for
it.
that point 2. Okay.
Yeah. Yes, sir.
That point 2 and the drop for the current, that will give you the delta V1.
Understand, sir.
And that delta V1 is the deviation, and your original value, so it will be 0.676. Okay. Initial value of V1 0 is 1, and the deviation is that value. So you will get the ultimate for bus 1 during fault will be 0.76. Okay. So I think that is now clear. So we can move forward to address the other bus issue. As 336 mentioned, if it is bus at bus 2, what will be the fault bus voltage? Z22 it will be, right? And in that case, the diagram orientation will be different. Now your short circuit path is attached to bus 2. Here you can see that, right? Is it observable?
Yes, sir.
Yes, sir.
Now we have the fault at bus 2. We have considered another scenario, second scenario for 3-phase fault, which is at bus 2 instead of bus 3. So you have to generate the equivalent impedance considering bus 2 scenario. Okay. So bus 2 scenario is there. So we can find the Z22 now, right? This equivalent impedance for that bus 2 will be Z22, and we have already ZF there. So the similar principle is applicable to determine as well as Z1. If it is Z1, that means bus 1 is attached. In that case, you have to find Z11.
So the equivalent diagrams are found by the Thevenin rule, right, sir?
Yes, Thevenin rule. Sorry.
Yes, sir.
Thevenin rule. So there you can see you have to readjust the diagram based on the bus fault location. Okay, Thevenin rule across that terminal of 2. So you have to generate that. In that case, the equivalent will be simpler than earlier one, because you don't need to shift now the conversion. You can generate that easily by parallel or circuit series, because these are parallel series and they will generate parallel, and they are in series, and that series is parallel with this branch. So we can find that easily for this second bus fault scenario. So likewise for all the case, that means if it is a bus 3 base fault or bus 2 fault or bus 1 fault, if it is balanced 3-phase fault, you can find so. Okay. So the principle is same. Now the thing what we have already mentioned, that if it is Z bus, the Z bus is given, the second scenario. It was based on which the Thevenin equivalent methodology, right? But
Yes,
if it
sir.
is in bus scenario like this one, if it is Z bus is given to you, okay, you can apply the information from that bus directly. Already
Yes, sir.
Sabrina mentioned that if it is given, you can use that, but sometimes it may not be given. So you may have two possibility in terms of Z bus, whether it is given or you have to generate by yourself. If you have to generate by yourself, you can generate it by bus building algorithm concept Z bus, or you can generate it by Thevenin equivalent circuit, right? You
Yes,
have
sir.
two possibility to generate that Z bus, two method to address that fault calculation issue. So if you have been given Y bus, actually from where you can get that Y bus? If you can
So
recall from where we
the
can
single
get the
line
Y
method,
bus?
sir. একদম first এর দিকে শিখেছিলাম তো, sir.
Okay. If you have been given single line, you can generate Y bus by
Yes.
inspection method, right? By
Yes, sir.
inspection method, you can generate based on KCL concept. SQL equation, you have to apply that to generate your Y bus. The self admittance, mutual admittance, Y11, Y12 like that. And you can generate that as well. So if it is given single line diagram, you can also generate Y bus. Y bus by inverse matrix, you can generate Z bus. So you have actually different possibility to address the problem, right? Whichever is the method or whichever is the path you can follow based on the given information. Okay. What is given there, you have to follow the path to generate your own idea to solve that issue. So if it is given Z bus already, that Z bus is there, so you don't need to bother about Thevenin equivalent circuit. You can use that Z bus for three-phase fault or balance fault calculation. So Z33 is already there, this value, you can use that information. So now can you say that which methodology is better or which one over other? Like what you have asked me earlier, can you answer by yourself which methodology you want to apply for solving this short circuit fault calculation?
This one?
That
Yes,
means
sir,
bus
this
building
one.
algorithm.
Yes, sir.
This one is more easier to you right now, but at the
Yes.
very beginning it was difficult because you don't have the idea for bus building algorithm. But when you have got that idea,
Yes.
that methodology will be easier for you.
Yes.
Initially it was okay with Thevenin equivalent, but if the circuit is complex, in that case, that will be difficult to address Thevenin equivalent. That thing I have mentioned when I started the discussion for bus building algorithm, why you have to use bus building algorithm. Probably Tasin has asked me this question, if you can recall.
Yes, sir. Yes,
Right?
sir.
Z bus building algorithm,
Yes,
why we should use Z bus? If we can manage that by Y bus instruction. But
yes,
if
sir.
it is addressed by bus building, it will be more convenient for you to address that issue. But sometimes it is required to check your Thevenin concept as well. So try to check the question first, answer those questions. Okay. Whether it is mentioned you have to solve by Thevenin equivalent or not, you have to follow the question accordingly. If it is mentioned in the
Yes, sir.
question that you have to solve the problem by Thevenin equivalence concept, you have to apply that. Okay, remember that. So the bus voltage you can manage. It's already done. V1F, the fault voltage, which is already mentioned. And when you have the fault bus voltage, you can also manage the line current as well during fault. Okay, between different line. So that was the discussion actually regarding this course. And beside that, you have another aspect of covered already, I think, by your lab course, short circuit capacity for those issue in the system for three-phase. Actually, the idea is you have to apply this short circuit formula for capacity over admittance or impedance. That means if the short circuit MVA is given, or if you have been get the idea, you can apply that short circuit capacity MVA over the impedance or admittance which you have generated through Thevenin equivalent concept by yourself. So CC, short circuit capacity for the system will be the impedance in capacity over the capacity over the impedance or admittance information. So that's the discussion all about today regarding that syllabus. Now, if we can again go back to the course objective or that scenario or the syllabus which I have already delivered to you at the beginning of the course, let's check the what is the syllabus. overall topics, whether we have covered all the thing or not. Another thing regarding Viva aspect, what is the other course have you managed regarding the Viva aspect? I think some part of the course mark is assigned for that part also. What the other teachers are doing? Has they taken any Viva?
Sir, for which? I mean, it was the theory.
Theory, regarding theory?
Sir, regarding theory, 24 January to 29 January.
24 January to 29 January, the Viva phase.
Yes, sir.
And have you assigned the course date for this course, the power system course?
Sir, ভাইবা ডেটটা মানে আমাদের হাতে দেওয়া হয় না, আমাদের শুধু বলা হয়েছে গ্রুপ লিস্ট, মানে গ্রুপ লিস্টও না, জাস্ট স্টুডেন্ট লিস্টটা চেক করাইছে। আর থিওরি যে পরীক্ষার রুটিন, ওইখানে আপনার পরীক্ষাটা হচ্ছে গিয়ে 21 তারিখ সম্ভবত। স্যার ডেটটা জি স্যার লাস্ট মানে ফাইনাল এক্সামের লাস্ট যে ডেটটা ওই দিন আপনার পরীক্ষা, এতটুকু মনে আছে। আর ভাইবাটা মনে হয় আমাদেরকে করতে দেয় না আর কি, ওটা মনে হয় স্যাররা করে দিবেন।
আচ্ছা, একেবারে লাস্ট পরীক্ষা 21 তারিখ লাস্ট পরীক্ষা। আচ্ছা ঠিক আছে, আর কনফার্ম করে দরকার হলে আমাকে আবার মেসেজ দিও কনফার্ম ডেটটা।
জি স্যার, জি স্যার।
আর হচ্ছে যে আমরা মোটামুটি কোর্সের শেষ করে ফেলছি টপিক ডিসকাশন। উই ক্যান চেক ওয়ান্স अगेन what we have discussed in this course regarding overview of power system, per phase analysis of symmetrical three-phase system, modeling of power system components, representation single line diagram, per unit representation, network topology, bus formation by inspection method, bus impedance matrix formation by building algorithm, importance of power flow problem regarding there is classification of different bus like PV, PQ and other bus scenario, load flow study, development of power flow model using Gauss-Seidel load flow, power flow, numerical problem, computation for transmission line flows, losses, slack bus power, Newton-Raphson method in polar form, the comparison between two methodology for load flow study, need for fault analysis, common approximation method for fault analysis, symmetrical short circuit even in equivalent fault, its application, short circuit capacity, circuit breaker, fault analysis using Z-bus, unsymmetrical short circuit analysis, symmetrical component method that you have already appeared in the last quiz, derivation of fault current, different fault scenario like line to ground, double line to ground, short circuit, development of interconnection of sequence network for like positive sequence, negative sequence and zero sequence network. So we have tried to satisfy those course objectives which we have already mentioned. Representation of a power system by drawing its single line diagram or one line diagram, draw the impedance diagram and reactance diagram from single line diagram for the power system, start current and bus voltage during fault or regular time. If it is symmetrical fault, which is three-phase fault, calculating symmetrical components from unsymmetrical phasor like ABC sequence, right? You have ABC current, unsymmetrical phasor quantity, and draw different sequence network which is positive, negative and zero sequence network for power system. Devise the line current, bus voltage and unsymmetrical fault, single line to ground fault, line to line fault and double line to ground fault using symmetrical components and sequence network. Those objectives we have satisfied regarding this course, and I think I have tried my best to give you the idea regarding this objective. Course objective I have already mentioned. We have tried to satisfy those 5 course objectives in terms of this power system 2 course. Besides that, you may have additional power system course. If you are interested, you can continue that probably in third or fourth year. Those who are interested, they can extend that idea for power system third course. Okay, so for the time being, we have tried to get the idea in terms of fault calculation, in terms of load flow analysis, in terms of single line or one line diagram or impedance diagram. How can we formulate those diagrams, and the numerical Gauss-Seidel numerical method, Newton-Raphson numerical methods for short circuit analysis, as well as different open circuit fault issue. So we have tried to cover lots of things in this course, and try to actually your final semester course will be covered after mid syllabus. Okay, so after mid we have tried to cover load flow. From load flow and what we want to cover, the bus building algorithm as well, right? Load flow bus building algorithm concept, and then we have tried to cover the sequence component, sequence network, positive, negative, zero sequence, fault analysis in terms of unsymmetrical as well as symmetrical fault for different scenario, like single line to ground, double line to ground, line to line scenario. Try to apply those result for that, and this is actually the issue what we can achieve. Okay, that's the summary of this total picture of this course. So from your side, if you have question or suggestion or anything, what is your feedback regarding that course?
স্যার মিডের আগের সিলেবাস তো বাদ, তাই না?
হ্যাঁ, মিডের আগের সিলেবাস থাকবে না ফাইনালের জন্য, কিন্তু মিডের আগের সিলেবাসের ওই থাকবে, সিলেবাস লাগবে না, কিন্তু সিলেবাসের কন্টেন্টে যে জিনিসগুলো কন্টিনিউয়েশন আছে সেগুলা তো মাথায় রাখবে আবার, ঠিক আছে?
স্যার কোয়েশ্চেন প্যাটার্ন ফাইনালের
question will be, I think, your marks distribution, you know already, 25% from mid and 25% from semester final.
জি স্যার।
So I think time will be the same, right? And during mid, what was the time duration? It was 1.5 hours or something like that, or 1 hour. What was the time duration regarding mid? During mid?
It was 1.5 hours, sir. Right, sir? I forgot, sir. Oh my God.
Okay, if it is there, actually I have also forgot. So if the regular time and the duration will be same, I think, what is followed in mid, because the mark distribution is same. The 25% mark like mid, like semester. So the question will be, I think 4 question will be there. 4 question will be there. You have to solve all, and you will get the idea. We have tried to cover after mid load flow study, right? Load flow study, the PQ solution, PV bus, which is covered in third quiz as well, right?
Yes,
PV bus,
yes.
PQ bus. Then we have covered the bus building algorithm based on 3 different rules: rule 1, rule 2, rule 3. Like branch 2 rule is attached to branch idea, 1 rule is attached to link idea. So using those 3 rules, how can you formulate Z bus? Or if the Z bus is given, how can you address the new Z bus? Like if it is line for line removed, how can you address the new Z bus? Those things was covered. As well as if you have been given some sequence unsymmetrical phasor in terms of voltage or current, right? When do you get unsymmetrical phasor? Probably this will be your last class. So if you have any question, you can ask regarding anything.
Sir, আমি একটু স্যার ফাইনাল কোশ্চেন প্যাটার্ন আস্ক করি স্যার।
হ্যাঁ বলো। হ্যাঁ বলো।
Sir, before, sir, when we had our normal physical classes, sir, so you used to give, sir, like 4 questions in terms of the mid question pattern. you used to give questions that were had sections, sir. So in this online version, there will be no sections. There will be only one question, that is question 1. Then one question, question 2. Is it like this?
Yes, maybe this one will be
like there
and 4 question without any subset, maybe one full set question. But in that question, you may have sub question, like question set 1 may some part, not AB, but some part, subsection. Okay, like you have to address different fault, single line to ground or double line to ground in same problem. It may be there, but not AB.
Okay.
That may be there. 4 set question will be there.
Okay.
1 hour probably. I think 1 hour. 1 hour.
So 1 hour এ 4টা কোশ্চেন স্যার কিভাবে স্যার?
স্যার মিডের মতো হলে ভালো হয় না? মিডে যেরকম 1 ঘন্টায় 3টা অ্যানসার করছে।
হ্যাঁ স্যার, আপনি 3টা দিয়েছিলেন স্যার, ওটাই বলছিলাম স্যার।
মিডে 3টা দিয়েছিলাম তো, ফাইনালে 4টা থাকবে। ফাইনালে 4টা থাকবে। আর হচ্ছে যে তোমার
টাইম বাড়াই দিবেন স্যার?
টাইম বাড়াই দিতে হবে। টাইম তোমাদের হচ্ছে যে ওই তোমরা কুইজে
জি স্যার, টাইম লাগে
তো 2টা করে দাও 40 মিনিটে। কুইজে 40 মিনিটে 2টা করে দাও না, সেই হিসাবে তো 80 মিনিটে 4টা দাও।
ওটা বিষয় একটা জিনিস বলার ছিল স্যার। স্যার এটা দিয়ে আরেকটা কথা স্যার, একটু কুইজে একটু মার্কস টাস বাড়িয়ে দেন স্যার। কয়েকটা জায়গায় একটু স্যার একটু অনেক বড় হওয়ার কারণে স্যার একটু শেষ করা নিয়ে একটু ডানে বামে টানাটানি হয়েছিল স্যার আমাদের একটু স্যার। স্যার অনেক কষ্ট হয়েছে স্যার, অনেক কষ্ট হয়েছে স্যার।
আচ্ছা ধরো তাহলে টাইম হয়তো বাড়াই দেওয়া যাবে। ধরো কুইজে কতক্ষণ দেওয়া হয়, 2টার জন্য 40 মিনিট দেই, সেক্ষেত্রে ফাইনালে 4টা দিলে 80 মিনিট। আচ্ছা ঠিক আছে, দেখা যাক, 1.5 ঘন্টা হয়তো দেওয়া যেতে পারে।
হ্যাঁ স্যার, 1.5 ঘন্টা স্যার ভালো হয়, কিন্তু এটা আপলোড টাইম ছাড়া স্যার। ইয়েস স্যার, আপলোড টাইম ছাড়া যদি আপনাদেরকে লেখার জন্য 1.5 ঘন্টা দিতেন স্যার তাহলে ভালো হতো।
কেন 80 মিনিটে তুমি ইয়া করো না, 40 মিনিটে 2 সেট দিলে 80 মিনিটে তো তোমার 4 সেট হিসেবে হয়। আমি যে কুইজ নেই 2 সেটে 40 মিনিট করে দেই।
হ্যাঁ, ও 45 হ্যাঁ হ্যাঁ, ইয়েস স্যার, ইয়েস স্যার, ঠিক আছে স্যার। হ্যাঁ হ্যাঁ, সো 1 ঘন্টা 20 মিনিট অ্যানসার। ইয়েস স্যার,
অ্যানসার। আর বাকি 10 মিনিটস হচ্ছে আপলোডিং টাইম। আই থিংক
আপলোডের জন্য। ইয়েস স্যার,
দ্যাট উইল বি সাফিশিয়েন্ট। হ্যাঁ, এটা মনে হয় বেটার হবে অপশনটা। ঠিক আছে, আমার মনে হয় 4 সেট থাকবে। তোমার হচ্ছে যে 1 ঘন্টা 20 মিনিট থাকবে রেগুলার এক্সাম টাইম, আর 10 মিনিট ফর সাবমিশন। আর সাবসেট হিসেবে এবি থাকবে না, ফুল সেট হিসেবে হয়তো থাকবে। এটা একটা ইয়ে। আর যেটা বলা শুরু করলাম, লোড ফ্লো স্টাডি, তারপরে Z-bus building algorithm, then we have tried to cover the symmetrical phasor quantity, like symmetrical phasor, if it is given unsymmetrical component, we can generate that symmetrical phasor, right? The positive, negative, 0, ABC or 0, 1, 2 shift, we can find that in terms of voltage or current. It may be in terms of voltage, it may be in terms of current. So that will be there, as well as the sequence network and component, like different fault scenario, single line to ground, double line to ground, or line to line. Those things will be there. Probably different fault aspect in terms of Thevenin or Z-bus. Okay. So 18 exam time and 10 minutes for submission. The total 1.5 hour for total exam. That will be final schedule or final exam planning.
And sir, what about the viva, sir? Will there be any
টাইম শিডিউলটা এখনো জানি না। টাইম শিডিউলটা জানলে হয়তো এর পরে জানানো যাবে, বা এটার ব্যাপারে তোমাদের সিআর এর মাধ্যমে পরবর্তীতে জানানো হবে। ঠিক আছে?
ওকে স্যার, এখানে কি আপনি মিডের আগের জিনিসপত্র কিছু স্যার জানতে চাবেন, বা ওই ক্ষেত্রে কি আমাদের নলেজ রাখা লাগবে স্যার ডিটেইলে?
হ্যাঁ, ভাইভাতে তোমার পুরো টপিকসই থাকতে পারে, কারণ ভাইভার জন্য তো সিলেবাস বাউন্ডারি নাই। ভাইভাটা হচ্ছে কোর্স ওয়াইজ ভাইভা হবে।
স্যার সিলেবাস বাউন্ডারি তো ওই যে মানে যে পিডিএফটা আমাদের দিছে আর কি, নতুন মানে কোর্স, ওখানে লেখা যে ফাইনাল এক্সাম হচ্ছে গিয়ে শুধু মিডের পরের সিলেবাসের মধ্যে, আর ফাইনাল এক্সামের 2টা পার্ট, ভাইভা আর রিটেন। তো তাহলে স্যার সিলেবাস তো সেম হওয়ার কথা না?
ভাইবার জন্য কি ফাইনালের সাথে ইয়া করা, নাকি ভাইবা পুরো সিলেবাসের উপরে?
না স্যার, ভাইবাও ফাইনালের সিলেবাসের উপর, যে পিডিএফটা মানে আমাদেরকে প্রোভাইড করা হয়েছে, যে কোর্স
আচ্ছা
মার্কস ডিস্ট্রিবিউশন।
ফাইনাল হোক আর পুরা সিলেবাস হোক, তোমাকে তো জিনিসটা জানতে হবে, ঠিক আছে? পুরা সিলেবাসের রেসপেক্টেই তো তুমি এই জিনিসটার থেকে বাইর হচ্ছ, তো তোমাকে আসলে জিনিসটার সবকিছুরই আইডিয়া রাখতে হবে। এখন যদি তুমি 2 মাস আগের কোর্স এখনই না মনে রাখতে পারো, তাহলে তুমি 4 বছর পরে কিভাবে কি করবা ভাইবা দিতে গেলে?
না মানে স্যার ওইটা না আর কি, হচ্ছে কি ভাইবা একদম টানা 6 দিন, তো মানে ভালো মতো প্রিপারেশন নেওয়ার সময়টা খুব দেয় নাই বলতে গেলে। টানা 6 দিনে 6টা
আমি
কোর্স।
বুঝলাম, আমি তোমাদের কথাই বুঝলাম যে ধরো আমি ভাইবা তোমাদের এই ফাইনালের উপরে নিলাম, কিন্তু আমার কথাটা ওখানে থাকলো যে তুমি যখন 6 দিন বা যেটাই বলতিছো, সেটা এখনকার ডিউরেশনে যেটা বলতিছো, ধরো 6 মাসের প্র্যাকটিস বাইয়ে, তুমি যখন 4 বছর পরে এই কোর্সের রিলেটেড তোমাকে ভাইবা নিবে ভাইবা বোর্ডে, তখন তো তোমাকে এত ডেফিনেশন বা এত সুযোগ দিবে না। তখন তুমি ওই 50টা কোর্সের সিলেবাসের রেসপেক্টে তোমাকে ভাইবা বোর্ড ফেস করতে হবে। তো তোমাদের জন্য আমি সহজ করে দিব, ফাইনালের ভাইবা হয়তো ফাইনালের উপরেই রাখবো, যে তোমাদেরকে জানানোর জন্য বললাম যে তোমাদের ওই মানসিকতা থাকা দরকার, ইউ হ্যাভ দ্য মেন্টালিটি টু সাপোর্ট দ্যাট আইডিয়া to cover the course. Otherwise, when you complete the graduation, the viva will be from total 4-year topics. Okay, so your mental maturity should be reached in that level. Otherwise, ওই পার্শিয়াল ভাইবা বা পার্শিয়াল কনসেপ্টটা কিন্তু তখন মানে থাকবে না। এটা তোমরা মানে নিজেদের জন্যই মাথায় এইভাবে মানে ইয়ে করো, সেট আপ নিও। আমার কোর্সে হয়তো আমি ওইভাবে ছোটখাটো নিয়ে নিব, সমস্যা নাই, কিন্তু তোমাদেরকে লং রানে ইউ হ্যাভ টু take that in your mind, that you have to face the total graduate course in a single viva when you complete the undergraduate. Okay, that's my actually what I can say, my suggestion or my guideline regarding your attending viva fear or something like that. আচ্ছা ঠিক, আর আমার দিক থেকে মনে হয় বেশি ডিসকাশনের কিছু নাই, তোমরা তোমাদের ফাইনালের জন্য প্রিপারেশন নিতে পারো।